Insect Newick review of Ghanavi et al. 2022 phylogeny of Erebidae, which is a moth family. Data is on the publisher's page here. You can see here, supporting information. Perhaps this should be the default place for machine readable tree. Otherwise, it's kind of this is kind of a disjunction. I having some other location you can, so it's directly associated with the paper. But also probably it should be made available at multiple repositories in case one becomes unavailable. Now I suspect this is the case for when publishers change hands or something. Sometimes I see for some older articles in certain systematics journals, seems like these older supporting information becomes unavailable. So that's one thing to consider, but generally I think better to make machine readable trees available, perhaps two places, one being the publisher's site and on a data repository would be ideal. So you have Bayesian maximum likelihood and Rogue. What they've labeled a folder as Rogue Newick. I think this is a software for rogue taxon inference. Let's look at maximum likelihood. Now, lessons to be learned here. So we have 3 trees. You can tell what they are by the names: amino acid, nucleotide without third codon, and nucleotide. Now, if you just looked at this, you may pick one of these at random. However, when you read if you then go and read the paper, you'll see the ML analysis of the amino acid dataset resulted in very anomalous trees, which means we should not use this one. Now, you wouldn't know this, so effectively this requires, if there's any, say someone working on synthesis or someone trying to reanalyze the data has to go and read it. Effectively, you're making them read the whole paper, because one of these is, well, to roughly speak, one of these is no good. Now, this is normal. Authors don't label their preferred tree or a tree which should not be used. This goes for machine readable trees and figures. To date, I've only still, after compiling several hundred published trees, I've only once come across where an author has explicitly stated their preferred tree, and that was for a figure. So for this reason, ideally, the file name of the preferred tree should clearly state preferred tree, and then that would then mean anyone reanalyzing or synthesizing their result would not need to then go and read the whole paper to determine this. So yeah, I mean, no one does this, but this is just a suggestion. It would make things easier downstream when we're building the insect tree of life. Onto the tree, we have, look at the top here, very first line, so Nexus format. Nexus format, you'll get the often definition of the labels, and then the tree may or may not contain a label. So see, Nexus format is in various ways quite inconsistent. You can see here it actually has the full labels, whereas sometimes Nexus you have just numbers, and then you have up on the first part it will define a label for each number. Well, this is just an Nexus format. And we have node labels in square brackets. And we have two components / separated. So script to parse this. Just remove these node labels and branch length. So onto the main component which we need to process in order to synthesize downstream. So we have a code underscore family name, and then we have the word unassigned, either starting lowercase and the word unassigned starting uppercase, or we have a subfamily name. Some minor variation in the code. So maybe a lesson here also. One main issue is maybe you want to parse the subfamily name, and that would be the third item from the end. So going from the right hand side, we have the species, genus, and subfamily. Now the problem is here, particularly here, the word unassigned. Some people might do this, but it's written in the exact same format as a subfamily name, i.e. single uppercase followed by multiple lowercase. So if you wrote some code to pull out subfamily name and you defined it simply as the third component, uppercase followed by multiple lowercase, then you would also pull this out, thinking it was a subfamily. A way around this would be to you'd have to specify the ending in INAE. But anyway, this would be simplified a lot if there is a vertical pipe character, which I would recommend as a delimiter. Then you could quite easily separate the binomial from the rest, which is less often used. Some minor inconsistency. So we have in this one we don't have the subfamily name, and we don't have the field itself. I.e. it's not been written unsigned, but only it's a minor issue. And we have 3 species repeats. So if you have a species repeat, you would expect this to be monophyletic. And if it was, you wouldn't be surprised. If it wasn't, then that would be a bit more interesting, and that would kind of justify their presence. Maybe keep these in, but these are 3 species. These are all monophyletic, so these are not really needed. Maybe there's some other reasons they're here, but I haven't really checked in that detail. Otherwise, I think that's it. There's 5 species ambiguous terminals, but all of these are the only represented genus, so these are informative. I've kept these, and that is all. And so not too difficult to process. This is moth families are relatively. Some of them are quite well studied. Maybe compared to your average family in the big 4 of the insect orders. But here we have the processed version. And one thing I just remembered I haven't checked yet is the routing. I need to look at the figure. So yeah, I mean, this brings up a couple more suggestions. You might try and find the outgroup on the specimen table, and I don't see the word outgroup or ingroup on the specimen table. That would make it a bit easier. But here we have the main plot in the tree, and looks like we should be looking for notodontids. Let's search for one of these and see where it is. Okay, and yeah, so this is not rooted. Good job we checked this. So we have Thornotopia, Notoplusia, Acrogaster, and Philera. So this is the outgroup here. So we need to root here. Then export, and that's it. Job done. Processed.